Okay, here we are. Last section for the first test, test 1, covering sections 2.1 through 2.5, kind of skipping 2.4. So here's what 2.5 is talking about: derivatives for formulas, derivatives of formulas. The formal definition of derivative to find a derivative function. So formal definition of derivative we talked about in the last section: limit it as h approaches 0 of f of x plus h minus f of x all divided by h. Which is really, if you remember, that's really not h down there. It's really x plus h minus x because it's slope, but then that simplifies down here down to just h. Okay, so you need to know all the rules of derivatives: power rule, constant multiplier rule. The constant multiplier rule is one we didn't spend a lot of time talking about in class because it was just kind of common sense. So if you're wondering what that is, that's something like this. The derivative of this function, well, it's being multiplied by a constant of 4. So therefore, when you do this derivative, you just ignore the 4. Do the derivative of the power rule. Bring the 3 out to the front, subtract 1. So now you just take your numbers in the front and multiply. That's the constant multiplier rule. It's just leave it alone. Sum or difference rule, that's the other kind of sum or difference means adding or subtracting. That means break your problem up into several parts. You need to know natural log, derivatives, exponential functions, either e to the x or a to the x, product rule, and chain rule. Okay, so let's do some practice problems. Oh, excuse me, and marginal analysis, which marginal analysis just means how much it costs to produce, or how much it costs to produce, or how much profit you're going to make on the next unit. So not your total, but just the next one, how much that will make for you. We did not do a lot of this in class, so I will just, if you're watching these videos, good for you, because that means you're going to know. I'm not going to test you on that in this test. I'm going to hold off on that topic so we can talk a little more in class. So we'll either do that on a quiz or the next test. Okay, so just practicing some derivatives. Using the formal definition of derivative, find f prime of x for this function. So for this one, formal definition of derivative, all right, so that means f prime of x is equal to the limit as h approaches 0 of this function. So everywhere I have an x, first thing we do is replace it with x plus h. So that will give me x plus h squared minus 3 times x plus h plus 2. All over, excuse me, not all over. That's just your first part. Then minus, now we just need the regular function. X squared minus 3x plus 2. Now that's all over h. There we go. Now, I would like to just be able to substitute in 0 for h, but I cannot because I'd be dividing by 0. So we're going to algebraically simplify this numerator and hope it works out nicely. So x plus h squared is x squared plus 2xh plus h squared. Distribute this 3, so negative 3, so it's going to be negative 3x minus 3h. There we go. Plus 2. Then don't forget to distribute your negative signs. That's going to be negative x squared plus 3x minus 2 all over h. Now let's do some simplification. Negative x squared and positive x squared subtract away. Positive 3x and negative 3x are going to subtract away. And negative 2 and positive 2 subtract away. That is leaving us with the limit as h approaches 0 of 2xh plus h squared minus 3h all over h. So the good news here is we see our h's will factor out of the numerator, which will leave us with h times 2x plus h minus 3 all over h. So the h's now divide. So now we're able to actually set this equal to, or substitute in 0 for h. So that means I'm going to be left with 2x minus 3. And that is your derivative of your function. So we go back and look. The original function was x squared minus 3x plus 2, and we know using the power rule, that would be the exponent comes down, making it 2x minus 3. So perfect. We saw it both ways. All right, next few problems. We'll look through these real fast. These are more for your checking. So here we go. We've got a chain rule here because I have a function inside another function, a power rule. So 10 comes out to the front, leave the junk alone, subtract 1. So subtracting 1, excuse me, can't scratch out, it's giving me a hard time. Alright, let's try this again. There we go. Alright, so, and don't put your hand on the slider. There we go. Alright, so subtracting 1 giving us 9. Now, the derivative of the inside, the derivative of the junk, because we did the outside parts, now I have to do the derivative of the inside, so that would be 2x minus 1. There we go. Alright, next problem. This is an exponential function. Alright, so the derivative of an exponential function, which that's one of the rules you need to know. I apologize, my notation right here, I should have f prime of x equals right here. Okay, so then, here we go. F prime of x is equal to, alright, exponential function says, whatever the exponential function is, just rewrite it. Alright, then multiply by the natural log of the base, so it's natural log of 4. Alright, so now that we've done that, we'll scratch out the 4, and so we ignored the junk, so now we do the derivative of the junk. So times, again, another chain rule. So times, alright, derivative of a 3x, or sorry, x cubed is 3x squared minus 5. Done. And now we've done the derivative of all of this. So we're done. Okay.